Okay, so you all are in web and cloud security. Hopefully you're in the right place. Let me introduce myself. I'm Wu-chang. I'm a professor here in the Department of Computer Science. I teach mostly security courses. I do teach the cloud course. So why are you taking this class? I always like to start my classes out with some motivation. Why am I sitting here doing all of this work? And hopefully I can convince you to not drop the course if you really like this stuff. So this is going to be my spiel to hopefully convince you that you're not wasting your time here. So if you just read any of the news articles out there, you can find that web and cloud security issues are having a real-world impact. In fact, the response by the Iranians to us assassinating their military leaders is likely going to be a cyber attack. And it's likely going to hit some sort of web or cloud infrastructure or critical infrastructure somewhere here. They're preparing. So hopefully we have our defenses up. We don't actually, but hopefully, hopefully we realize how vulnerable we are. And this is sort of funny because actually when Stuxnet happened in 2010, the response by the Iranians was to DDoS our bank websites. And at the time, President Obama was thinking about a retaliatory strike, cyber strike against that attack, but he opted not to because he was too fearful that we were more vulnerable than they were. And that situation hasn't really changed much. So the fact that Donald Trump decided to push the big red button means that we'll get to see exactly how vulnerable we are. So hopefully we'll get to see some of this in real time. If they do some exploits that actually fall under some of the things I'm going to talk about, that'd be kind of interesting. I wouldn't say cool, but it'll be interesting. So there are plenty of examples of this actually mattering. So the whole Edward Snowden leak, where he was able to uncover all of the activities that the NSA was doing and led to this pretty big brouhaha over the last decade. All of that was because he was able to take a simple web crawler and scan the internal websites of the NSA to pull out all of this information that he then loaded up onto a disk and flew to Hong Kong with. Okay, so this is what can happen. Mass data exfiltration can happen if you don't pay attention to web security. This is the DBIR report, is the data breach, I forgot what the IR stands for, but it's a report that Verizon produces every year, and they talk about web application issues being the #1 cause of data breaches in any organization. And this, if you lose your crown jewels, it can be game over for your company. And it was almost game over for Equifax. So Equifax had this web vulnerability in Apache Struts, and this is something that you'll be exploiting towards the end of this course. They had this unpatched exploit, and it allowed someone to get into their internal systems, do some reconnaissance in their network, and then pull out all of the, basically the credentials of all of us who, whether we knew it or not, had our information on Equifax, which turns out a lot of us did. 143 million of us actually had information there. Okay, so this is the first time I've added the cloud security stuff to this course. So you notice it used to be just called web security. Now it's web and cloud security, because it is often the case that a web exploit is leveraged in order to exploit the cloud. If it's hosted in the cloud, it's used to exploit a whole bunch of back-end cloud resources. So they go hand in hand, and it's often the case that you're hosting a web application in the cloud. So that's why I'm doing both of those in both of these in a single class. So here's an example from earlier this year. where an SSRF, and I'll talk about what an SSRF is. This is a web vulnerability. How that was leveraged in one of these provider sites to basically give the adversary root access to all of the computing instances in that cloud platform project. So that's a pretty good jailbreak on an organization, and you hopefully don't want to have one of those happen to you. But of course, it did happen. So in the summer, the Capital One breach happened with an SSRF that allowed the adversary to go into a storage bucket and basically pilfer all of Capital One's consumer financial applications. So this was a web vulnerability pivoting to full jailbreak on the storage resources of an AWS project. We will be doing several exercises that emulate this particular breach. And then in terms of other issues with the cloud, poor web security or poor web application security can lead to complete jailbreaks of what are known as API keys. So API keys are used to authenticate, often used to authenticate over the web, not only the web, but within cloud projects. And if you have exposed any of these keys, it's basically the keys to the kingdom, this happened 2 days ago. I decided to throw it in there because it's a current event. So Starbucks basically left some essential keys in a GitHub repo, which is a no-no. Okay, so why has this become so important? We used to just teach buffer overflows, and you got a program you're running locally, and it's got some bugs in it, and you can get root access on your machine. Well, as it turns out, we have the internet happen to us, and so this course has occurred because now the web is being used as a carrier for every single application that we use. And so, moreover, most of these applications are hosted on cloud, in cloud providers. And so you find that for all the major news articles about security breaches, they almost always involve one or the other. Some kind of exploitation in the web and the cloud. So we really need to have more skilled practitioners to ensure that this stuff doesn't happen. But this is the problem is that we have this what they call a cybersecurity skills gap. And the take-home here, there's a lot to read on this slide, but the take-home here is that there is a huge, they estimated a 2 million person shortage of qualified cybersecurity professionals. There's a whole bunch of people who want to do cybersecurity, but there's a certain level of skills that are needed in order to actually do cybersecurity, and they're estimating we're falling really far behind. So, which is good. The classroom's almost full, so hopefully we can get at least some of you out there to well, I don't know, maybe in 2020 it'll be 1.99 million instead of 2. So this course, I'm going to start with a very fast primer on how the web works. And then it's all about common classes of web and cloud vulnerabilities. And so these things are constantly evolving. And so this course is constantly evolving. And in fact, the course I taught 2 years ago, some of this stuff is completely obsolete now. Those vulnerabilities are dead. And they're replaced with new ones. And it's important to note the ones that you're going to do this quarter, some of those might be dead next year. And then you'll have to keep on learning what the new ones are. So I cannot stress enough that this is not a point-in-time sort of course that you can stop learning about after you're done taking this class. This is something that you pretty much have to keep on learning in order to stay relevant in this field. But one of the things that this course does help you with is training an adversarial mindset. Because when you have that, that's a generic skill that you can point to any of the new classes of vulnerabilities that you might come across. Okay, so there's a ton of hands-on practice doing these exploitations in this class. That's one of the things that I prefer when I offer a course. And these exercises they're meant to demonstrate the overall vulnerability class. Some of them are they're hokey. They're kind of crafted, and they don't seem realistic, but it's supposed to just show you what is going on in terms of the vulnerability class. This will be followed, so I'll talk about the vulnerability. You'll get hands-on sort of practice exploiting them, but the other piece of this course is prevention. So it's not enough to be able to break into everyone's stuff. Like eventually, if you get employed, you're going to need to help defend against this stuff. So we'll talk about the different prevention techniques. And this is really critical for all of you in a CS program because y'all are generating the security problems. In fact, I am generating them. And so you are in a unique position where you might be developing the security chops to solve them and be able to do something about it in your code base. So when you go out in the real world and somebody is using a SQL statement directly sending it to a backend, you'd be like, no, I should use a parameterized query because you've taken this class. And if you don't say that, don't tell them that you've taken this class, because hopefully that's part of me passing you in this course, is that you know not to use SQL in the wrong way. Okay, so hopefully something you get out of this class will be useful to you in your career. So the format of this class, I'm a big fan of doing the bottom, practice doing and practice teaching others. But I have to do a bit of lecturing up top so that you know what you're doing. I try to minimize the amount of talking that I do, but I try and cover enough material, so I can't get rid of the lecture, but you'll be doing a lot of the bottom. And so this learning pyramid, if you've seen it before, this is the amount of retention that you get is on the bottom. So 75% and 90%, that's pretty good. That's what we'll be trying to focus on. And so the way we do this is to do a whole bunch of CTFs. So for those of you who don't know about security, CTFs are capture the flag exercises. These are sets of challenges that have been sort of pioneered in security competitions. But we've adapted at Portland State. Charles Wright and I have put these throughout our security courses just because we're big fans of the format. So we've adapted CTFs into all of the courses. If you've taken 201, that's a CTF what we developed and we sent into the regular curriculum. But most of the time we're doing CTFs in the security courses because it's just a format that's taken off in our field. And so the idea behind CTF levels is to understand and apply a security concept towards capturing a secret hidden flag that a level might have. And so by showing us you've gotten the flag, we understand that you have been able to exploit the vulnerability on the back end. And so there's like hundreds of different CTFs that are out there. Most of them are targeted to specific things. There's like a reverse engineering one, there's a crypto one, binary exploitation, cryptography CTFs. We are mostly focusing on web and cloud security CTFs in this class. And so the idea is to not only give you knowledge, but give you practice developing the skills to exploit these things. Okay. I talked about the format. So one of the things about how this class is going to run, I am going to give you a lecture material that talks about the concepts, and then hopefully give you enough time after I talk for you to start the exercises, to start the lab work. Every single concept has a set of labs that I want you to do to immediately apply what you've just been taught. And so that is going to happen in class, and I really encourage group work in class. So this is why attendance is mandatory, because you'll find that you'll do the work much quicker when two minds are better than one, that you'll be able to group together. So for all of the labs, the lab assignments, you're going to be in here, and you can, outside of the class, meet with a friend to work on these things together as well. But like in class, there's going to be a lot of group work time. And so you can brainstorm on how to solve all the different lab exercises here in class together. But for every single lab, I'm going to have you do a write-up. And the write-up has to be done individually. So you can figure out the level as a group, but the write-up and the actual mechanics of solving it, they all have to be done individually. And so that's the way we're going to do this is with a lab notebook. And this lab notebook will document using screenshots and some answers to questions that I'm going to ask you. That will document that, yes, you have done the lab. You have gone through the lab individually, even though you came up with the solution as a group. So that's what I'm going to have you do. There are also homework assignments and programs in this class. And these are supposed to be done individually. So no group work on the homework site and the programs. So for the homework site, it's at this link, CS495.org and CTF.org. Levels will be opened up and closed as we go along. If you go there now, nothing's opened up. You just have a login. I'll talk about that in a second. I'm going to have you set up an account, hopefully in this class. There are 2 programming assignments, and these are Python programs that allow you to programmatically attack specific web vulnerabilities. And so I do assume knowledge of Python, so I think that's our 161 course. But if you don't have Python, you have to be willing to learn it on your own without much help from me. I do have a screencast that I go through from the cloud class. It's like a 1.5 hour sprint through Python Essentials. You can watch that. It's linked from the course website if this is your first go around with Python. The screencast is derived from Lubanovic's Introducing Python. So if you want a good reference book, I prefer this particular book for teaching out of because it's very concise. It's a small book, which is what you want in Python, because Python is meant to be concise. So that's why that book is selected. I want to go through the syllabus, which is basically the course website, which talks about the topics, the grading, the attendance, and the final project. So that's what I'll do next. So this is the course website. Let me see here. And then that's my contact information up there. I prefer all communication to me to be done via Slack. I'm very bad with email. And so if you can, that's my handle on the PDX CS Slack. The channel is there. If you click on that link, if you don't have a Slack account and you click on that link, it'll ask you to create one. Anyone with a pdx.edu domain can get added to this Slack. If you have some issues in the class that you would like to send me anonymously, I have this link. I think I had, yeah. You can click on that link, send me a message, and then you can anonymously send me some feedback. My office hours, I haven't figured out my office hours yet, but they'll be posted there. That's the departmental page. Let's see here. So on the right, course slides will be on the Google Drive. There's that link to the screencast. I will be putting all of the screencasts that I record here on a channel, a media space. This is a link to the lab site. So eventually, all of your labs will show up here. Right now, only one does. Hopefully one does. And this is your first assignment, which is this setup, which I'll get to in a bit. Link to the course homework site, the description, which I already talked about, the schedule, which is going to be a work in progress. These are all the topics I'm going to cover. And the very first homework is linked there. This is what I'm going to have you do after I'm done talking. And the first homework is to set up all of your accounts. There are a boatload of accounts. that you're going to be needing to set up and configure. I'm going to have you do all of that after I'm done. Hopefully it doesn't take too much of your time with the talking. Okay, so I went through the labs in the notebook on the left. There's a rubric here that we're going to be using when we grade your lab notebook. This is the information about the homework and the programs, and then the final project, which I'll get to later on in this course. But the final project will be for you to solve an open-ended set of CTF levels of your choosing. So you can pick and choose the kinds of exercises you like, and then we'll be doing that as your final project. Okay, these are my policies. So I grade attendance. That's 10% of the grade. The homework site is 30. The programs are 15%. The lab notebooks are 30, and then your final project is 15% of the course. Okay, are there any questions about the course setup in the back? No midterms, no exams, just the final project. I decided to let you work through finals week and then make the final project due at the end of finals week. So that's why there's no final exam. So we're not meeting the final exam slot. That hopefully you take those 2 hours and you do an awesome CTF level instead. That's the intent. And you'll be doing screencasts of your final project. So that's what I'm using the final exam slot for. I used to have everyone solve each other's levels by watching their screencast, but now I think just getting more reps through finals week would be the thing I'm going to have you do. Yes? I could after the, oh, that's a good question. Yeah, I can set up a shared channel and then have you upload your screencasts to that channel so that you can see solutions. Yeah, that's actually one of the, yeah, I sort of missed that people not being able to see. Yeah, I'll do a shared channel for people to watch all the other projects that people have done. And hopefully you choose different ones. There'll be a lot of different ones to choose from, so hopefully we'll get a nice smattering of levels. Okay. Any other questions? You had a question?
No, he didn't.
All right, cool. Okay, the last thing is some ethics. You're going to be learning some things that can let you get into other people's stuff. Don't get into other people's stuff because that's a felony, actually, from the CFAA's perspective. So I have pre-selected sites that are intended for you to break into. You won't get in trouble. Like, for example, the cloud stuff, all of those vulnerable cloud projects, those are mine. I don't mind you breaking in. If you run all the credits down, I would sort of get upset, but it's like, okay, I can ask Google or AWS for more, but like all the stuff for this course, you're fine hacking into. Just don't point these skills to any place else unless you've been given permission. Typically what happens when you are a penetration tester is that you write a contract with the person that you're doing the work with, and it has the ground rules of exactly what is allowed and what isn't allowed. There was this case a couple of months ago where these folks broke into a city hall or a municipal building as part of a pen test. The police arrested them, and now threw them in jail, and the police are like, that wasn't part of the operations. But they were clearly thinking that it was, like breaking into a local government building was apparently part of the pen test. It was for some part of the government agency. So anyway, the ground rules have to be very explicit before you go and do stuff like that, is what I should say. Okay. Okay, so now I'm going to get to homework 1, which I've already shown you. I just sent you a Google Cloud coupon. I sent it to everybody registered and everybody on the waiting list. So you should have that. do not redeem that coupon in any other way except the way I talk about in this code lab. And the reason is that almost every quarter I have people applying coupons to the wrong account, to their private Gmail rather than their pdx.edu email. And so you'll see that there are some, I'm going to skip ahead, there are some very specific things that I want you to do to set up that Google Cloud account. Yes? Nope, you'll get another billing, well, the only issue is that you go to a different billing account. And then you'll have different projects that you'll be creating a separate project. If you've taken like the cloud class, you already have an account and a project set up. When you do this, it'll work. In fact, actually, yeah, so you'll have a different project name, so it'll be fine. You'll just have multiple billing accounts, which is fairly easy to navigate. But it's really important that you follow these instructions so that you get the money to the right place. So I wanted to mention that. Some of the other things, I have people do this policy agreement that acknowledges that they've read the ground rules for what is allowed in terms of group work and what is meant to be individual work that you're not supposed to share code on, and that's what this statement is. So I want you to write that out and sign it and then bring it to class, next class. Instructions on the Slack account are there. All of your code submissions are going to be done through GitLab, so hopefully you have some experience with Git. If not, this is a nice walkthrough. There's some links here, primer on Git and some of the Git commands. I prefer if you use Visual VS Code for your work, you can download the Git extension, and then you don't have to memorize any of the commands. It's basically clicky clicky, and your thing's committed and pushed, which some people like. So these are instructions. Obviously, if you have a GitLab account, you probably don't need all of this stuff, but this is there for those who, if this is your first time through Git, you'll probably need to walk through this pretty carefully. So these are the instructions of setting up your repository for the project. Your program submissions will be done as Git submissions, as well as your final project. I'm going to have you at least give me the URL for your screencast, and then I'll also have you any source files that you have created for your final project will be in this Git repo that you create. The other thing I want you to do is install. This is optional, but eventually you're going to need a piece of software that is able to capture web requests going through your system, edit them, and resend them. Now you can use, I like Postman, but there's a tool called Burp Suite. So we'll be doing a bunch of the port swigger exercises. They have a community edition of something that they call Burp. You can use that. You can use the open source version of Burp, which is called Zap. You can use, what other things are there? You can actually use the browser itself to capture requests and resend them. I just, because we're in a CS department, Postman is actually used in multiple places around town. I know this because I got a PSEP student who was like, yeah, you should have everyone use Postman one class, like 2 years ago. And I was like, oh, wow, this is sweet. So you might run, like if you're, for API testing especially, this is a de facto tool that they're using to test APIs. It's not really a security tool per se, but we're going to be using it for security features. You'll find that for the functionality for this class, Postman is fine. For some of the more advanced web security things, you might need something like Burp or Zap that actually knows a lot about enumerating attacks and doing some other automated attacking. So here are the instructions for installing Postman. There are two pieces, an interceptor, and then there's a bridge. And so this can be tricky. So if you run into any installation issues, I would appreciate that the troubleshooting happen on the Slack channel so that people, because I don't have a Mac, so I can't troubleshoot problems with a Mac. I have a Windows machine, I can troubleshoot that, but I haven't tested Postman on multiple platforms, so hopefully we can group debug that kind of thing. The next thing I want you to do is create a port swigger account. These are the folks who have written Burp Suite. We're going to do their free Web Security Academy. We're not going to do all of it. We're going to do some of the exercises in this. As a final project, you can go through the rest of them. or not the rest of them. That's probably, there's way too much there for you to do as a final project. But like the ones that are interesting to you, you could do a subset of those as a final project. But I want you to create an account on this site. This is the homework site. You all have accounts. If you were either registered or on the waiting list, you have accounts on this site. The issue with this site is that it needs usernames that are at least 5 characters long. Turns out some people have Odin IDs that are 4 characters long. So if you have one of those Odin IDs that are 4 characters long, your ID is that thing twice. So that's what I did. The password for every single one of you is CS495 595 right now. When you log in, it's going to ask you to change it. When you change your password, change it to something trivial that you don't use for any other site. Because as it turns out, this is all done over HTTP in the clear. So that anybody monitoring a wireless network will see you log in with your credentials. Now, no one is going to voluntarily solve all your levels for you, so it's not that big of an issue, but still. Yeah, if they do see a login credential that you're using for your bank, that's a problem. Okay. That's the homework site, the Google Cloud Platform account. So creating a project, associating billing to that project based on the coupon that I give you. That should all be done. I used to run this class in the Linux lab, and I used to have you run these vulnerable sites in VirtualBox. Because this is being done in a classroom, a regular classroom, what I am going to have you do is run the vulnerable site on Google Cloud, and then you can hit it from here. The problem is that this thing is vulnerable, and we don't want other people to compromise it, and then run all your credit, run a crypto miner, and then take your $50 of Google Cloud credits and give you nothing back. So when you run these vulnerable virtual machines, I believe I have it ACLed so that it only allows access from the 131.252 subnet domain for the prefix of Portland State. So you will find that you won't be able to access this VM when you spin it up from home unless you use the VPN to get a Portland State address. You can go in there into the VM. Every one of you will run your own version of these VMs. You can go in there and you can add your home network to the network ACL. I can show you how to do that, but just know that I've restricted access to these VMs to the Portland State domains. Okay, so this will give you the instructions for creating it. I have these 2 images. So the way this works is that when you create a virtual machine on Google Cloud, when you specify your image to boot from, over in this Custom Images tab, you'll see this project. This is my project for the course, CS495-Web Security. And this is shared out throughout our Portland State organization. You should see this WFP1 and WFP2 image. These are the boot disks that you'll use to spin up versions of the 2 vulnerable VMs here. Okay, when you spin it up, you'll get an IP address here. You just click on that, and then that should bring you to these exercises, Web for Pentester exercises. So if you have trouble getting to this, that's when you can start posting to the channel, and whatever errors that you're getting onto the channel. Okay, so it's similar for Web for Pentester 2. The only difference for Web for Pentester 2 is that it needs at least 1 gig of memory. And as it turns out, the F1 Micro on the smallest machine on Google Cloud is like 500 megabytes. So you need the next larger machine in order to run this particular VM. So on this, the only caveat is that you use a G1 small when you're specifying the size of the VM. And it'll be pretty explicit where that configuration happens when you create the VM. Okay, the other thing that we're doing at the end of this class is a whole bunch of AWS hacking. So in order for that to happen, I need all of you I have created a classroom in AWS Educate. And the way you sign up for this classroom, I think there's like a $50 credit per student in this classroom. So you click on that thing, make sure you click on this link. Don't go to AWS Educate by itself. You want to actually you want to click the course view equals true link, because that will bring you to a UI that will allow you to find my course. So this, you type in Portland State University, it automatically updates this dropdown, and hopefully there's only one CS495 course in this dropdown. You select that, and then you join it. There is a process that you have to follow to get enrolled. It's like an email verification thing that AWS Educate does. And then hopefully you get all the way to the end, and then you will, if you get this, you're good to go for the rest of the course. So let me know if you are unable to get to that point. Hopefully this week. Hopefully this is done within a day or two to get yourself all set up. So that's all the course logistics for this class. Yep.
The last time that I had to use the Google Cloud VMs, I really struggled with just not knowing how to use the platform.
Mm-hmm.
Do you know of any like Google Cloud 101 tutorials, site sources, or anything like that, just to help with that aspect?
Yeah, so the problem with that is that everyone runs into some crazy different thing. Every time they use Google Cloud Platform, there's like a dozen different checkboxes and creating a virtual machine. So I don't know of one that might, if you post specific issues, I'd be able to point you to things. But yeah, I don't know of a really good, I mean, I could probably search YouTube for, well, actually, there's not a lot of YouTube content on Google Cloud Platform.
Just like understanding what the status of your VM says and that kind of stuff.
Oh yeah, the UI, yeah. I don't, yeah.
Actually, I took Earl Price class last term, and he has like a walkthrough for setting up the VM as well, and then also to get it so that you can have it on your
Oh,
everything. So in order to interface with it.
I should talk to him. Yeah.
You could ask him about that.
Is it a link on his website? No, I'll just steal it. He won't mind.
So maybe. So,
Okay, if you could post that on the Slack channel, that would, yeah. Yeah, my Google Cloud usage in this class is not that much. Well, actually, I do have, I should take that back. But yeah, if you could post that, that would be great. Okay, so that is the first homework. I am going to pause here and take a 5-minute break before I give you some of the basics. You could actually start setting up your accounts during this break, but let me just pause here.